first one is introduction to IC engine. We know that the IC engine can be classified into two. That is, first one is 4-stroke and second one is 2-stroke. So I will give you this flow chart to you, this PPT to you. You can refer later. Okay, and we will start from here. The internal combustion engine can be classified according to different criterions. Okay, the first, it can be classified according to 7 categories. Okay, the first one is according to the type of fuel used. The first one is petrol engine, and second one is diesel engine. And according to the cycle of combustion, it can be classified into 3. The first one is Otto cycle, second one is diesel cycle, and the third and important one is dual cycle. And according to the method of ignition of fuel, the first one is spark ignition, and the second one is compression ignition. The spark ignition comes in petrol and gas engines, and the compression ignition comes in diesel and vegetable oils. According to the number of strokes in cycle, it can be classified into 2-stroke and 4-stroke engines. And according to the position of cylinders, it can be classified into 5. The first one is horizontal engine. It can be used in already used in Hero Hondas, and the second one is vertical engines. It is used in cars, bus, and truck engines. And the third one is V engine. So we already discussed about V engines in this figure. So this figure shows, figure A shows a V engine. Okay. And the fourth one is radial engines. It is used in old aeroplane engines. And the sixth one is according to the method of cooling, water cooling and air cooling. And according to the speed of the engine, it can be classified into 3: slow speed engines, medium speed engine, and high speed engines. Okay, so these are the classifications according to different criteria. So this is a normal cross section of engine. Okay. The next one is part of IC engines and their materials. The functions and materials of different parts of an IC engine are classified, are discussed below. The first one is cylinder block. As you can see, so this is the cylinder block. That means, I'll tell you. So this figure in the left hand side shows the cylinder block, and this is a rough sketch of the cylinder block. I think you all can see this. Hello?
Yes, sir. Yes, sir.
Okay,
Yes, sir.
Yes, sir, you can see that.
okay. The left hand side figure shows the cylinder block, and it is a rough sketch. So the main function of the cylinder block is to serve as a support and enclosure of moving parts. So here this is the moving parts, the piston, the crankshaft, and the connecting rod. These are the moving parts. So it acts as an enclosure for these parts. And the cylinder block is a type of section between the cylinder head and the crankshaft. So the piston, above the piston, it is called cylinder head. Can you see this mouse? Movement of mouse?
Yes.
Yes.
Okay. This portion represents the cylinder head, and the remaining this portion represents the cylinder block. Okay. It includes liners, pistons, and it also includes water cooling jackets, and O-rings. So it includes this piston, and there is also liners. So we can't see that liners, and water cooling jackets also there for reducing the heat. And the material used for cylinder block is grey cast iron and aluminum alloys. Any doubts? Hello?
No, sir.
Okay, good. The next important one is cylinder head. The function of cylinder head is to enclose the cylinder block. So this is our cylinder head. The cylinder head comes on the upper portion of the cylinder block. So these valves, these springs comes in this cylinder head. Okay, it acts as an enclosure of the cylinder block, and the gaskets are provided tight leak-proof joints at the interface of this cylinder head and the block. So in between the cylinder head and cylinder block, there we place gaskets for leak-proof type joints. If gasket is not there, there is a chance of leakage of the combustion gas from the cylinder. Okay, for that we use gaskets. And it also serves as a passage for the flow of water cooling. So cylinder heads also serves as a passage for the flow of cooling water. And the cylinder head is made up of grey cast iron or aluminum alloys because it has good castability and damping capabilities. So castability means it is very easy to cast. That means castability. And damping means it is the ability of a material to absorb energy by converting mechanical energy into heat. That is called damping capability. So this is a rough sketch. The right hand side shows a rough sketch and it includes two holes on the upper side. That means it is that hole is for valves, inlet valves and outer valves. Okay. Hello? Any doubts?
No, sir.
Good. The next one is cylinder liner. The problem of cylinder wear is considerable and this has been solved by cylinder liner. So you can see when the piston is moving up and down, that is the reciprocation movement, there is a chance of wear and tear. So it can be reduced by the liner by adding the cylinder liner. Okay. The cylinder liner are of two types. The first one is dry cylinder liner and second one is wet cylinder liner. So there is also a rough sketch that showing the dry cylinder liner and wet cylinder liner. Okay, as you can see in this figure, in the center figure. And the right hand, the extreme right hand side figure shows the normal cylinder liner. Okay. And the extreme left hand figure shows the wet cylinder liner. And there you can see the water jackets, water cooling jackets for the liberation of heat. Because when the piston is moving, they produce intense heat. This can be reduced by water cooling jackets. Okay. And dry liner is not in direct contact with of cooling water, so it is called as dry liner. So there is no direct contact with water, so it is called dry liner, and hence it is known as dry liner. And the thickness it ranges from 1.5 to 3 millimeter. So the thickness of the dry liner is 1.5 to 3 millimeter. Okay, and the next one is wet liner. It is in direct contact with cooling water, so that's why it is called wet liner. That means the liner has direct contact with the cooling water. Okay, and it can be replaced easily. So the materials, the cylinder liners are in the form of barrels. So you can see its shapes in the form of barrels and made up of special alloys of iron containing silicon, manganese, nickel, and chromium. So we already told about these gaskets. It is used for the tight fit and leak proof joint in between the cylinder head and the cylinder block. Okay. So the function of gaskets are: the gasket is placed between the cylinder head and cylinder block to retain compression in the cylinder. The gaskets prevent leakage of gases from the combustion chamber and ensure tight fit joint. So we already discussed that. The gasket also withstand high pressure and high temperature. Okay, so these are the main functions of gaskets. Okay, the various materials are used for different engine gaskets are asbestos and synthetic rubber. And if for exams you need to draw like this, that is this right hand side figure, you need to draw like this. Okay, and you need to write these points also. The next important one is piston. So this is our piston. This figure, you can see 4 pistons. Okay, inside this cylinder block. Can you see this mouse? This cursor?
Yes, sir.
Yes, sir.
Okay, so this is our combustion chamber. These are the 2 valves, and this is our piston. Okay, so let's start pistons. The function of pistons are enlisted below to transmit the force of explosion to the crankshaft. So after the power stroke, what will happen? After the power stroke, the piston will move from top dead center to bottom dead center. So we already discussed the engine terminology, where we discuss the what is top dead center, what is bottom dead center, what is clearance volume, what is set volume, what is compression ratio. We all discussed in the last section. Okay. Any doubt? If you have any doubts, please ask about what is top dead center, what is bottom dead center. Any doubts?
No, sir.
No, sir.
Okay, so you all know aware about that. Okay, good. So to transmit the force of explosion to the crankshaft. So in the piston, in the cylinder, in the combustion chamber or in the cylinder, there is only the up and down motion, that is the reciprocation motion. So we need to convert that reciprocation movement into rotary motion by using crankshaft. So that we use connecting rod. With the help of connecting rod, we can translate or transport that reciprocation movement into corresponding rotary motion. For that we use connecting rod. So the piston, the function of piston is to transmit the reciprocation moment into corresponding rotary motion in the crankshaft. Okay. To form seal, so that the high pressure gas in the combustion chamber do not escape into crankshaft. So if the piston is not there, there is a chance of the escape of this combustion gas. After the combustion gas, after the power stroke, there occurs the combustion gas. There is a chance of leakage of this combustion gas into the crankcase. Okay, so this can be prevented by this piston. So it also acts as a seal. Okay, and to serve as guide and bearing for small end and connecting rod. So the connecting rod contains small end and big end. So the piston is connected to the small end by using gudgeon pin. So it also serves as a guide for the small end and connecting rod. So these are the main function of the piston. Okay, to transmit the force of explosion to the crankshaft, to form a seal so that the high pressure gas in combustion chamber do not escape into crankcase, to serve as a guide and bearing for small end and connecting rod. So these are the main functions. Okay, and as you can see in the center figure, this is a normal drawing, a rough sketch showing the piston, the cross section of piston. So you can see this is a piston head, and this is the supporting valve, and this is the piston pin boss, and you can see three grooves, that is called ring grooves. Okay, three ring grooves you can see, and a drain hole and a piston skirt. Okay, so this is a common piston, and the extreme left hand figure shows the piston, the four piston that moving, reciprocating in a cylinder. Okay, the next one is piston ring. Any doubts?
No, sir.
Okay, okay, good. The next one is piston ring. So what is the purpose of this piston ring? The piston rings are placed in the ring grooves of the piston to maintain good sealing between piston and the cylinder valves or liners. So as you can see, this piston have three grooves. Okay, please reply. Can you see these grooves?
Yes, sir.
Okay, so this piston have three grooves. Okay, that means we have three compression rings. The first ring is called top compression ring. So that will comes on the top of the grooves, first grooves. And the second ring is called intermediate ring, and the third ring is called oil control ring. So the first top compression ring, the function of the top compression ring is to give a seal and the tight the fit joint of the piston. Okay, and the second intermediate ring is used to supply or used to carry the heat from the piston to the cylinder valve, and also it supports the tight proof the seal. It acts as a seal also. And the oil control ring, it will supply oil to the piston and the cylinder valve for to reduce wear and tear. So these are the three rings and their three operations. Okay, so this is our ring. So we have total three rings. So the bottom right corner you can see the piston, the cross section, zoomed photo of this piston. There you can see the first one is the top compression ring, second one is the intermediate ring, and the third one is the oil control ring. And there is also a rough sketch that showing the ring diameter, ring gap, ring width, and ring face and radial thickness also. Okay. So next, the function of piston rings are enlisted below. To form seal for high pressure gas from combustion chamber which prevents the leakage of gases. So this is for top compression ring. To provide ease passage of heat flow from piston crown to the cylinder wall. So this is for intermediate compression ring, and it maintains sufficient lubrication of the cylinder wall. This is for oil control ring. So these are the main three operations. Okay, the piston rings prevents the flow of oil into the combustion chamber. So there is also a chance for the going of oil from piston to the combustion chamber. So this can be prevented. Okay, and these are the main functions. The materials, the rings are made of fine grain alloy cast iron. These materials has excellent heat and wear resistance quality, and the chromium plated rings are used as top ring. That is, top compression ring is made up of chromium plated ring, which are subjected to highly working pressure and temperature. Alloy steel has been used as rings materials. So these are all about these piston rings. Okay. Any doubts?
No, sir.
Okay. Good, good. The next one is crankshaft. So the main purpose of this crankshaft is to convert the reciprocation movement into corresponding rotary motion. So we need rotary motion. Okay. For that we use crankshaft. The crankshaft is important part of transmission system which converts the reciprocation motion of the piston into rotary motion, which helps in connecting rod. Okay, and you can see the in the left hand side, left hand image, right hand image. The one shows the piston, two shows the connecting rod, and three shows the flywheel where the energy is stored, and the fourth shows the crankshaft. In the left hand side image shows the flywheel mounting flange and the crank web, oil passage, crank pin, counterweight, and main journal and keyways. Okay, so the material in cast crankshaft, both cast steel and spheroidal graphite irons are used as crankshaft material. These shafts are high strength, ductility, and toughness. Okay, so this is a rough sketch showing crankshaft. So for example, you need to draw like this. Okay, and the eighth part is camshaft. So this is our camshaft. In the right hand top right hand figure shows this camshaft. There we have cams. So this oval shape, semi-oval shape shows this camshaft, and this is used. These cams are mainly used for the timing opening of valves, inlet and exhaust valves. And there is also a rough sketch for this camshaft also. Okay, the camshaft is simply a shaft which cams are mounted. The cams is rotary member which imparts reciprocation motion to another member called lifter or follower. So the function camshaft is responsible for the opening of valves. Camshaft has two cams for each cylinders. As you can see, so this is our valves, inlet and outlet valves. Okay, so for one cylinder or one piston, we have two valves, inlet and exhaust valves. Okay, and the gear is presented on the camshaft, which drives the ignition, distribution, and oil pumps. So the materials, the camshaft is forged from alloy steels or cast from hardenable cast iron, and it is case hardened. Case hardened means the hardening the outer layer of the metal while the inner layer became softer. So that is called case hardening. So this is all about camshaft. So as you can see, this is our camshaft figure, a rough sketch. You need to draw like this. These are cams and this is our bearing. Next important one is connecting rod. So what is the purpose of connecting rod? It converts the reciprocation movement of the piston into rotary motion of the crankshaft. As you can see in this figure, so this figure, can you see this figure?
Yes, sir.
Yes,
Okay,
sir.
so this is our piston and this is our crankshaft. These two are connected by a link called connecting rod. Okay, so this connecting rod helps to convert this reciprocation movement into corresponding rotary motion. Okay, so for that purpose we use connecting rod, and it connects the piston to the crankshaft. It joins piston pin to crank pin. The materials, the connecting rod is either forged of steel and duralumin. This material is compact and lighter. The connecting rod is also cast from malleable or spheroidal graphite cast irons. You can see in this figure, this is a rough sketch that showing the connecting rod. It has a small end and a big end. The small end is connected to the piston and the big end is connected to the, we have two valves, inlet valves and outlet valves. Okay, so this figure shows this in the valve. Okay, the schematic diagram of these valves. Valve has head and face, stem, and spring retained lock grooves. Okay, the function of the valves are enlisted below. The valve is a device to open and close a passage for charge. As you can see here, where, so here. Okay, so this is valves, inlet and exhaust valves. And when the valves are closed, they must seal the combustion chamber tightly. So when the valve closes, there is no movement of combustion gas or anything. It's perfectly closed. Okay. The material for valves are discussed below. The first one is exhaust valves are made of silicon chrome steel because of its good corrosion resistance and high hardness. Okay, so we use silicon chrome steel for exhaust valves, and for inlet valves are subjected to less heat, are made of nickel chromium alloy steel. So the inlet valve is made up of nickel chromium alloy steel and the exhaust valve is made up of silicon chrome steels. This is our camshaft, and this is our valves. This is our spark plug. For so anyway, the topic is cycle of operation in two-stroke and four-stroke engine. So first we are talking about the cycle of operation in two-stroke, that is petrol engine, that is spark ignition engine. With the help of spark, what will happen? The air fuel mixture will ignite and there we get the power. So in two-stroke cycle engine, the whole sequence of the event, that is suction, compression, power and exhaust are completed in two-stroke of the piston, that is one revolution of the crankshaft. As you can see in this figure, so here the one stroke means the movement of piston from the bottom dead center to the top dead center, that is one stroke, and the movement of the return back of the piston from the top dead center to the bottom dead center is called the return stroke, that is second stroke. So here the revolution, here the power is produced by the two stroke of the piston, that is one revolution of the crankshaft. So that's in this sentence. In two-stroke engine cycle engine, the whole sequence of the event, that is suction, compression, power, and exhaust are completed in two-stroke of the piston, that is one revolution of the crankshaft. Okay, from 0 to 180 degree, one half revolution, 180 to 360 degree, half revolution. That is one revolution of the crankshaft. So there is no valves in this two-stroke engine, only ports. We have total three ports. First one is inlet port, that is petrol inlet port. Second one is transfer port, and the third one is exhaust port. Can you see this mouse? The pointer.
Yes,
Yes, sir.
Okay, so we have total three ports. First one is inlet port, second one is transfer port, and the third one is exhaust port. And in the case of petrol engine, we have spark plug, and in the case of combustion ignition engine, we have fuel injectors. Instead of spark plug, we use fuel injectors. And you can see the piston, the connecting rod, the crankshaft, the crankcase, and the crank also. And you can also see the fins. The fins are used for the liberation of the transfer of heat to the atmosphere. For that we use fins. Okay. And so let's start. The upstroke of the piston, that is the suction plus compression, is called upstroke. Upstroke means the movement of piston from bottom dead center to the top dead center. So that is called upstroke. Okay. So when the piston moves upwards, it covers two of the ports, the exhaust ports and the transfer port, which are normally almost opposite to each other. As you can see in this figure, the left hand side figure shows this. That means we have total three ports: inlet port, exhaust port, and the transfer port. When the piston moves from the bottom dead center to the top dead center, what will happen? We can see that these two ports are closed. That means the exhaust port and the transfer ports are closed. Okay. When the piston moves upwards, what will happen is there occurs a pressure difference. That means inside the crankcase there is lower pressure and outside there is higher pressure. So what will happen is a proper amount of petrol and air mixture will enters to the crankcase. Okay, the fresh air fuel mixture will enters to the crankcase through inlet port. As you can see, this inlet port is open. Okay, and at the same time, the what will happen? The fuel air mixture, it contains air fuel mixture in between this combustion chamber. It gets compressed. This traps the charge of air fuel mixture drawn already in the cylinder. So in the cylinder there is already air fuel mixture that get traps. Further upward movement compresses the charge and also uncovers the suction port. So if the piston moves upwards, it uncovers the suction port and it traps the or compresses the air fuel mixture. Further upward, okay. Now the fresh mixture is drawn through the ports in the crankcase. So due to the pressure difference, what will happen? The petrol air mixture enters to the crankcase. And just before the end of the stroke, the mixture in the cylinder is ignited by a spark plug. Thus, during this stroke, suction and compression are completed. So at the end of the stroke, compression stroke, what will happen? The spark plug ignites and the power. That will happen up to this section. That means this upward stroke. I will tell you briefly. When the piston moves from bottom dead center to top dead center, what will happen? There occurs a pressure difference in this crankcase. That means inner of the crankcase there is lower pressure and the atmospheric pressure is high pressure. So the pressure, the proper amount of air fuel mixture from the carburetor enters to the crankcase, and when the piston further moves upward, what will happen? The exhaust and transfer port are already closed. Inside the combustion chamber, there is already a proper amount of air fuel mixture that gets compressed. And at the end of the section, what will happen? The spark plug ignites. So this will happen in the upstroke of the piston. That means suction and compression stroke of the piston. It includes power and exhaust stroke. Okay, it includes the power and exhaust stroke. I'll show you this figure. So the left hand side image shows the downward movement of the piston. Okay, so when the piston moves after the explosion inside the combustion chamber, when the spark plug ignites, what will happen? The pressure reduces and it expands. The expansion will hit the piston downwards. Okay, and what will happen? The inside the crankcase we have fresh air fuel mixture. That due to the downward movement of the piston, what will happen? The fresh air will pressurize and goes through this transfer port, and at the same time the exhaust gas port opens and the combustion gas will removed with the introduction of this air fuel mixture. Okay, so that happens in the downward stroke. During the fuel raise, the temperature and pressure of the gas which forces the piston to move down the cylinder. Okay, when the piston moves down, it closes the suction port, trapping the fresh charge drawn into the crankcase during the previous downward stroke. Okay, as you can see, when the piston moves downwards, the fresh air will enter through the transfer ports. And now the fresh charge moves into the cylinder through transfer port, driving out the burnt gas through the exhaust port. So the fresh air fuel mixture will drive out the burned gas through the exhaust port. Okay, so that will happens in the downward stroke. A special shaped piston crown helps in driving out the exhaust gas. So the piston is specially shaped. You can see in this figure. So this helps in removing the exhaust gas from this combustion chamber, and thus the driving downstroke of the piston power and exhaust strokes are completed. So this will happen in the downward stroke of the piston, power plus exhaust. Any doubts?